Hello everyone. So we are going to do question number 10, October 2023. So in this question, so the figure 4 shows a sketch of part of the curve C1 with the equation y is equal to 3 cos x by n degrees, so where x is greater than 0, and then this is the curve C1. Okay, so where n is a constant, so the curve C1. Okay, so here the curve which is given C1, and then cuts the x-axis for the first time at the point P, which is this is the point which is they have given, which is 270 and 0, and then as shown in the figure 4. Now state the value of n. Okay, so we need to find the value of n, and then also state the period of C1. Okay, so for what is the given equation? So can we write down the given equation? Y is equivalent to 3 cos x over n, right? So how to find the value of n? So it is very simple that the point P is given here. What is the point P, which is 270 and 0? So let's take the point P, which is 270 and 0. So here the 270 is our value of x, and then our value of y coordinate is going to be 0. So now, so we will plug the value of y is equivalent to 0 from the given coordinate, and then 3, and then cos of x coordinate is going to be 270 upon n. Okay, so this would be now, can we write down that 0 equivalent to cos of 270 upon n, and then if you shift the cos here, it would become cos inverse of 0, which is equal to 270 over n. And then we know that what is cos inverse of 0, which is going to be 90 degree, right? If you have calculator, you can type that cos inverse of 0, which is 90, and then 270 over n. So therefore our n is equivalent to 270 over 90, which is going to be n is equivalent to 3, right? So if you cut out these zeros, and 9 times 3 is 27, so that is our n value is going to be 3. So most of the concepts that here it would be like they will be thinking about stretch concept, so you don't need to worry about stretch. So here the given points, we have to use that given point and then do this question. So the value of part A where n is equal to 3. Now find the period of C1. Okay, so here if you take the curve, right, C1, so here basically our graph, right? So how it is a cosine graph is something which should look like this, right? So how many periods are there? So here 1, 2, and 3. So when n is equivalent to 3, right? So we need to find the value or the state of period, right? So for that we have for one period it is going to be 360 degree. So we have 3 periods, right? Here 1, 2, 3. So number of periods where n value we got it as 3, right? So one cycle is 360 degree basically for cos. So 360 times 3, which will be 1080. So value of our answer is going to be 1080. If you didn't get it, just n value, that whatever n value you get, always multiply with the n value, so 360. Okay, so that is how you get the value of period. Okay, our next part of the question. So this is the answer for part A. Now we are going to do part B. Okay, so the point Q shown in the figure 4. Okay, y is a minimum at C1. So here we can see the minimum, the point Q. This is the point Q. State this coordinate. So we need to find the value of this coordinate, which is Q value, right? So for that, we know. Okay, let's draw our graph. Okay, so if this is our basically what is our cosine graph? That's something it would look like this, right? Right? Yes. And then now here already we have, this is going to be our 0 degree. This is going to be our, okay, so already we got the n value, which is 3. And this is our 270. And then this could be our negative 3, right? So, and then let's look at basic general cost graph, which is going to be 0. This is going to be 90. This is going to be 270. This is going to be 360. All right. And then keep adding 90. And this point is going to be 270. So 270, 360 plus 90, that would be around, so here this point would be Q. So this could come around 540, right? So this is the point where we were looking. So this is the point. If you see 270 times doubled, which will be around 540, right? So 540, and where it is at the negative, right? So here it could be -1. So that would be our general graph. Here we are looking for, already we know that y is equivalent to what? 3 cos x upon n. So based on that, we can say that y is equal to, so we'll multiply this coordinate with 3. So 540 multiplied with 3, because y is equal to 3 cos, right? So this is for only cos, right? Okay. Now, and then multiplied 1 minus multiplied with 3. So that could be our 1620 minus 3 could be our answer for the part Y. Okay, part B of the question. Okay, so our coordinates would be 1620 and -3. If you didn't understand still, okay, so you can see that already we got the n value is how much? 3, right? So then we know general cosine graph. So this point could be how much if you take this is 270, right? And then this could be double of it, so 540. Okay. Or we can do the general cost graph. So this could be 1620 because it is not going to be double of it. So this is, if this is 270, so then this could also be add 270, add 270, and keep on adding and going on, and then we'll get 1620. But you can't if assume you have multiple graphs, right? So you cannot do that way, right? So we cannot keep on adding. If assume they have given 50 60 cycles, so how will you do that, right? So it is best to do with one cycle and then multiply with 3 cycles. All right, so I hope you have understood this question 10 part B. So now the curve for part C. The curve C2 has an equation y is equivalent to 2 sine x degree plus k, where k is a constant, so you need to find the value of k. Okay, so let's and then the points are given. R is equal to a 12/3, and then minus a and minus 3/5 are both lies on C2, where given that a is a constant which is less than 90 degree, find the value of k. Okay, so what is the given equation? Y is equivalent to 2 sine x degree plus k. Now let's plug the value of coordinate. So here it is x, y, and here it is going to be x, y. Okay, so let's plug the value of y is going to be here 12/5, which is equivalent to 2 sine, what is our a value? Which is, I mean, x value is going to be a plus k. So this is first equation. And then for the second coordinate also, we are going to plug the value. So what is the value of y, which is going to be -3/5, which is equivalent to, and then 2 sine, what is our x coordinate would be minus a plus k. So we know that there is an identity in trigonometry. Sine of negative theta is negative sine theta, and then cos of negative theta is negative cos theta, right? So based on this identity, so we can write um, this particular equation, negative sine negative 2 sine a plus k. Okay, so that is how we can write this is equation 2, this is equation 1. So now we are going to solve equation 1 and 2 simultaneous equations. So when we are solving, this would be cancelled, and then we can write k value would be 12 plus 5 minus of -3/5 when we subtract them, right? So that would be that would give us okay, so 12 addition, right? Which would give you, which is equal to k plus k is 2k, and then when you subtract this 12 minus 3/5 by 5, so since same base we can add the power, which is going to be 12 minus 3, which is 9 by 5 is equivalent to 2k. So therefore our k would be 9 upon 2 times 5, which would be 9/10. So this would be our answer for part C. I hope you have understood part C also. I hope all A, B, C is clear. If you want to take a screenshot, you can take it. Okay, so this is the answer for part A, part B, and part A. Okay, so I hope everything is clear. Thank you. See you in the next video.